Hello, welcome back on the 33rd Wro.cpp meetup. This event was planned differently, but it ends up with the online meeting. But happily, we have a really excellent speaker, and I think that will be worth seeing as well, even if online. So we are continuing our goal, which is making C++ specialists successful in their job. And from that perspective, I've made a kind of a plan what topics we need to cover. And today is one of the topics, which is plugins. So I'm happy that Sławek prepared the topic and will present it to you. So I'm still looking for your input. I saw that more and more feedback was delivered to me. So I'm analyzing that, and I'm looking for speakers that will cover the topics that you are interested in. So if you did not fill it yet, please do it. That's the address and QR code. The agenda for today is simple. So I'm doing the introduction, and later on the stage will take the Sławomir Grabowski with the topic about the plugins and how you can extend your application with them. Of course, we have plenty of social media channels. Do not hesitate to go there, promote them, like them. Whoever joins that, it increase our network, and we can go even further with our presentations. So if you are not there yet, please do it. And we have a web page that I try to keep up to date. On that page, there is also the feedback form, which you can fill out as well. But the goal is to create that kind of dictionary or a book with all our knowledge that we gathered during those meetings. And the goal is to collect all those topics and materials from all those topics that I've presented on the previous slides. And also we are on the Patronite, so if you want to support our community financially, feel free to go there and do it. And one of the best our patrons is Adam Badura, who I promised to advertise on my every and each meetup, thanks to his contribution. And okay, so please help me in welcoming Sławek on the stage. So Sławek, just share your presentation because I don't see it yet. And to all who are watching us, if you can write to us if you hear us, if everything is fine, that would be good, just before we will go further.
Okay, hello, I'm Sławek. Let's start. Please let me know if the code that you see is easy to read, or just I would like to test how what is the delay that we have. It's my first time that I'm streaming. Usually I lead the trainings or the lectures live, but it's my first time, so please be just nice. So today we have a topic called plugins. As Philip said, just let me change. Yeah. So today we will talk a little bit about the plugins. So who I am? I'm mainly C++ developer with 10 plus. I don't know exactly why, because I have some breaks in my career. I usually program in C++. In the let's say beginning of my career, I started with the UI mainly. Of course, I had some experience with embedded system, but usually my career was the 2D, 3D. I was always interested in the 3D graphics. I always wanted to program games or the game engines. And the game engines is what I do for the last 5 years. So I focus on the first in my startup. I was co-founder of the team in QuickTurn Studio that we developed the graphical framework for the embedded devices, for example, for the cars, whatever. Then and one company just took me and my team to the bigger project for the new operating system, which I also attend in the many teams. Right now, I'm a game developer and producer. In our team, we just decided to just switch to the gaming industry, and we developed the Whispers of Ellenrod games. Mix the fusion of strategy deck builder with some RGB elements. If you would be interested, I will just share you more info at the end. The presentation scope, what is agenda for today? So firstly, what is a plugin? Because maybe it's not the clear, especially from the programming perspective or just from the build system perspective. Why we would like to use the plugins, why you should consider or not, why you should not consider the plugins, some example implementation in C++, and at the end, if we will have a time, I will show you some tips and tricks how to deal with plugins with a nice way, how we can improve your build system in CMake. That will just will save us a few seconds, let's say, per each build, or how to deal with dependencies. And a very important thing, if you have any questions, something is wrong, or for example, I will lose connection, whatever, just let me or Philip know. I will ask some questions during the presentation. I'll wait a little bit because we have a small delay because we have a streaming. If it will be more complex question, maybe we'll park it later, but feel free just to ask the question any moment. Starting for the plugins, we would like to answer the question what the plugin is. So in general, from the build system perspective, we have a free type. From the bigger perspective, of course, type of artifacts. We have applications like executable. We have libraries, so the binary that we can reuse when we pack some logic in library, and then we can just merge it into or just connect it to the unknown library or the application. And you have objects, so when we have a translation unit, we can also deal with objects, but usually when we build a build system, we deal with applications and libraries. So plugin is a library, no surprise, I think. And then we can divide libraries from the, let's say, operating system perspective, or just the build system. We have a dynamic and static libraries. Static library is just the file that we use in the build system, and in result, when we connect a link from the application or the library, just the artifact is just static library is just built in. Dynamic library, however, is the file that is separated when we start application. Is just we choose when we load it or not, because for example, when we have let's say the game, and when we would like to just play the cinematic at the beginning, we can just load, for example, the codec, whatever, when we need it, and then when we just play the game, we don't need to have a logic responsible for playing the video, so we can just unload it. That's the dynamic library. And we can divide the dynamic libraries to the two categories. We have a shared and the plugin. So it's I usually have a feeling that people just not distinguish dynamic and shared properly. So usually shared is dynamic library, but plugin is also dynamic library. So what is the difference between shared and plugin? So shared library is what you usually deal with. So it's the DLL file or SO file, depending on the operating system that we are on. And shared library is just opened by operating system with the application start. So, I mean, when we run our application, the operating system checks every dependency, and if we use given function, then we open automatically our functions that we use, etc. Our plugin is opened by application, but we need to open it manually in the code in by DL open or just load library, depending on the system, because it is the platform specific. Similarly, when we like to close the connection with the library automatically for the shared library, and again, we need to close the connection with the library manually in the code. So the main difference is that the shared library is needed to start an application. Plugin is not needed. So when we are the software architect and we would like to, for example, turn off and turn on some features, or maybe we would like to separate given module to be as a, let's say, paid part, the separate from it, we can just disconnect the plugin, or just does not deliver it, and then we can deliver our software without that plugin. So why we should use plugin instead of shared library? So if we would like to deliver the software for someone else, and if you would like to extend the functionality, many cases, I will talk about it later, we can deliver the plugin separately. We can update even our functionality by just replacing the plugin or adding the new ones without updating the whole application. We don't need to rebuild entire software. We don't need to link, because we open it at the runtime. For example, we would like to deliver our software to someone else, and we would like to allow other programmers or their parties to extend our application. Another case, if we, or just the advantage, so if we deliver software, and if someone would like to extend our application, he can use different compiler, right? What we need to, what the provider or the plugin needs to guarantee is just keeping compatibility with the API on the many levels. Well, we will speak about it later. And about updating functionality, I already said. Okay, example scenarios. Just a very simple one. Probably you've met them. So, for example, we would like to support custom file formats. If, for example, we have a Photoshop or maybe another editor of the 3D graphics, 2D graphics, and you would like to support custom formats. So you develop custom format, or maybe we just released our image editor, but we would like to let others add new formats, because, for example, we just for now we support PNG, but if someone else would like to add the TGA or maybe JPEG 2000, maybe, then someone else can just bring us DLL to support that. What only we need to do is just to prepare the proper header file and just mechanic that will allow discover that given file, I mean library DLL, is just placed in the given directory. We need to specify this. We can add new components. Let's say we have an application that is the UI application, and if someone would like to provide us the other widget responsible for saving, editing, whatever, there is unlimited features of that you can use. If you would like to add new components, if, for example, we like to extend the functionality of the engine, for example, in graphical engines, for example, you can have a simple 3D object, but someone else can add, For example, the particle system that you can deal with is also the graphical object we can deal with it, and many others. So how to create a plugin from the build system is just we add library. The difference is that we put the module keyword right here. So usually when you create a dynamic library, by default we add shared, but my recommendation is module. If you met before the shared for library, probably it always work because it's just the same file. But the difference from the CMake perspective is that if you will try to call target link libraries and the target name will be our plugin, then CMake will tell you, hey guy, there is this library is a module plugin, you cannot link it. So it's just for the purposes of the build system that will prevent you to link. One important thing is if you would like to expose the symbols of given library, class, function outside, for the Microsoft Visual Compiler, we need to provide in given places just declare specification that it would be an export that given function can be used or accessed from the another place. And very simple example. So if we would like to, like I said, extend our application, so we would like to support custom format for the Blender, 3ds Max, or another 3D software. Mesh is just the 3D object. So we need to expose. We need to call load mesh file, and that's all. So application can open. I will show you how on the next slide, and then just call, and this is our implementation. What is required if we are software and you would like to provide extension mechanisms? For example, we need to deliver the proper header files like the include mesh.h, whatever. And this is how we deal it on the Linux. So we have application, we have example path to the library file. So it's my plugin.so. And we need to include the Linux specific header file. And we just call DL open. And we provide plugin path and some flags. We have many of them. I will speak about it later. For now, just assume that DL open. We get the handle that we can use for another functions, which is, for example, DL sim, which just loads the symbol, and we use just DL handle and the name of the function that we expose. So like here, this is like this. This is the implementation of the plugin, and this is the application that just loads open the plugin, and we look for this function there. And if we have a function, this is a function pointer, so we can call it. So this function pointer is just, and this argument is just calling this function load mesh file. We provide the file, and then we create a mesh, we return it, and that's all. Of course, to be nice, as I said in the previous slides, we need to close the connection. So we can, on Linux, we just call DL close, DL handle. Of course, if we, this was a simple example, here's a more complex one where we check if, for example, we can open, because we can, for example, we can make a typo in the path, or the path will be incorrect, then the library will be incorrect. So it's good to just check if that library was opened successfully. So we check DL handle variable. Then I recommend before calling the DL loading the symbols from that library, just clearing all the errors before, because if some error happened in the maybe previous loading symbols, just DL error returns us the string, the C string with the message from the last error. So to be sure that that last error is empty, we just call it before calling the loading symbols, and then we load the function pointer. We can check if given message is empty or not. If it's not, then probably we have an error. We can close the application, whatever. Then we close the connection to the library. Of course, if we would like to, you can have a different behavior of the application. And then if error is empty, then we can call our function pointer here. The first, okay, comparing to the Windows, similarly, we have a different functions. We have a different header file. So instead of DL open, we have a load library. For loading function, we have a get process address, and the rest is same. We use the same function pointer, and of course, we close the connection library by calling the free library. Do you have some questions at this point? Okay, I don't see any questions. We have a delay, but let me know. Please let Philip let me know if there's some questions. Okay, I present you this slide, but there is a small mistake that beginners usually do. I also did. It's forgetting about one mechanism, because when you have a get process address or DLSIM, okay, if we don't close it, probably depending on the build system, but probably the memory can be released in the not maybe on the hand behavior, but on unpredictable. So it's good to close connection with the library, because we need to release memory in the proper order. So in the complex systems, when we have many plugins, some plugins can depend on each other. So it's good always to close the connection to the library, because we are aware of when the given library is closed. So that's why. Okay, as I started, there is one mistake here. So because we look for the symbol in the address when we, for example, when you call nmdc command on the given library file, we can just print all symbols. So in this example, the symbol of this function probably with the 90% would be not load mesh file, but the compiler will add some, let's call it random marks, because we have a mangling in the C++. Mangling is just renaming the functions from the binary, because C++ allows to have same function names for different functions with the different arguments. So we just function overloading that we have in C++. In C, we don't have mechanism called function overloading. So we would like to say to the compiler, treat the code between these braces as a C code. So from the compiler perspective, okay, this is a C code. We don't support the function overloading, so we don't need to mangle the name of the function. So then we can use. So let's just see the example. It will, I think, will be the best. So I have a small build system right here. I have something like this. So I have a plugin loader. When I provide the path, and I call DL open, is a different flag. Let's skip it for now. Why I use the rtld global. I just call plugin handle, and then I call the get function for me. So the first problem in plugins is that we have with that load get process address and just load the symbol is what is exactly set in this function. We load the address. So the problem is that that operating system does not check the function signature. So we just get an address. So we can, of course, provide the function pointer, but compiler operating system will not check it for us. So our get function is just the reinterpret cast for the get function pointer, which is because I implemented the build system, operating system agnostic functionality. So we have a get function pointer. So I call dlsim and I just return the pointer. Yeah, just void pointer, and then I need to reinterpret the cast. So the first problem is that you need to care about, and there is no good way for just checking that. Probably if you will call that loaded function with the incorrect signature, you will just experience the crash or maybe incorrect behavior. If you, for example, access the correct address, the system will just not prevent you for accessing the memory for your application. So, but probably you error. So let's just simulate the example that we forget about that symbol. So let me just comment and we deal with the plugin sample. So I reload my build system. I implemented some fancy function that I would just target plugin dependency. So for now, my application is just loads plugins from the plugin directory, which is here. Just load plugin, provide directory from the plugins from the application directory, and I just load plugins from this directory. So plugin, it's here. So I have a plugin system and I have my plugins. So it's just plugin sample. It's just iPlugin, and the responsibility for that class is just providing the plugin info. So if we have a few modules, it's good to just describe your plugin because maybe you have a different modules. So for example, we can provide the name of the plugin, vendor, plugin version, or like in, for example, other plugin, which I will present you later, that we provide a module name, which is, for example, the graphics. Okay, so if we forget about C, so we will expect, okay, I run it, and this is my build system trick that I use, that I have a plugin validator. So probably I cannot find the function get plugin instance. If I provide it, then it's okay. Then my plugin is loaded. So that's important thing. If you would like to surround it by braces, you can. If you would like to put it in one line, it's okay. Okay, do you have some questions at this point? Okay. I presented you very simple example when we have a mesh which is delivered by us. But if you would like to extend functionality of the class, we would like to deliver new types. We would like to provide from our plugin new type to our application. Any ideas, quick ideas how we can do that? Maybe I presented the code, so probably the answer was already presented, but maybe you have some idea how we can just provide the custom type that our application will use from the library that our application haven't seen before. The answer is very simple. It's just use polymorphism. So the virtual, so the interfaces with the pure virtual methods. So in the application, if we would like to let others extend our application, we just create the abstract type. Of course, we need to deliver the headers with the classes declaration to allow inherit from them, and that's all. So, for example, we would like to provide the user to extend our application by adding the possibility to extend with the new file formats. For example, you have a music player. You would like to extend the functionality of your application to play new music formats. In this case, is just the mesh loader. So we just declare the mesh loader. Pure interface just get supported formats to, for example, to provide the information to application that class that will be returned, what kind of formats it supports, and importing mesh, exporting also if, for example, we would like to extend the editor and we would like to implement this interface in the plugins. And also it's good to create the factory function that it will create us the mesh loader. More about that modules and functions I'll present you later. So we have a mesh loader module that also we provide. So we have, of course, a default destructor, and we have a factory method, just get mesh loader, returning the pointer to our implementation, for example, object file loader. So we create our module file. This is implementation at the top of our plugin. So we present here that's the API which is the DL export required for the MSVC. Of course, for the Linux case, the definition is empty, so we need to just guarantee that macro will be replaced by no text to not treat it as a compiler token. And this is the name of the function that is required. And we implement our module, which will return the mesh loader. So from the 11th line, we have a usage in our application. So let's assume that we already have a plugin handle. We just loaded our plugin, and we just get the function get module instance. So we have a plugin module that just instance of this class. So that comes from plugin, and we just create the mesh loader. So okay, we have a mesh loader, and then we provide the OBJ file, for example, from the wavefront, and we have our mesh. We can do something with our mesh, and at the end, mesh is just the return by copy, but because we allocate the memory and we would like to have extra abstraction, so we need to use the pointers or the references. So then we release the memory and we exit our application. Of course, I skipped the DL close and closing the connection just to not mess in the presentation. You can do it in a more fancy way. So because we have a modern C++, so probably you just have just something in your mind why that guy used the wrong pointer. So there is an alternative way. We have a std unique pointer, and we just don't need to release our memory manually. But both implementations, like I presented, are incorrect from the design perspective. Is someone who has an idea where's the mistake from the, let's say, perspective from the architecture of our plugin system? We have two big mistakes, but let's say, firstly, I can give you a tip. Just sorry, the tip. Some small word that it is about memory. So this is a plugin implementation. So the main idea is that the memory allocated by a plugin needs to be released by a plugin. So the mistake that we've made here is just because the unique pointer is just
I think we lost you. A second for maintenance. Then. Okay, I just received the information that some issues with the internet on the Sławomir site, so he will be back in a second.
Okay, I'm back.
Glad you're here.
Sorry.
No worries. That's the way it is.
Happened.
Otherwise, I'm glad you're back. So just share your presentation once again.
And could you tell me when? In which moment we just lost the connection?
So
it seems that I've already shared the screen.
So that was, yeah, the screen is shared. Yeah. Yeah, I guess it was that. So
Okay.
you're talking about the default deleter.
Okay. Okay. So as I said, memory allocated by a plugin should be released by a plugin. So the design mistake here is that we just force plugins to allocate and deallocate memory in given way. So we don't give any choice for the plugin. You need to use new and delete for allocating the memory. So for example, if we would like to provide let's say the for the meshes or for the graphics, usually we would like to optimize our application, and if our application, I mean plugin in this case, we like to use custom allocator, we just prevent it. So you can say that because we have a unique pointer and we have a std for delete, let's okay, custom deleter, because some of you can just think that we can extend it by the custom deleter. It's not the good way also, because still we just force some way how the memory should be managed. So the custom deleter is just not an option. I mean, it's an option, of course, if you can do it if you would like to, but it's not a good option if you would like to have a very flexible way of dealing with the memory management. So one of the idea is using a share pointer instead of the unique pointer. Why? Because for the share pointer supports also providing the custom deleters, but the difference is that shared pointer supports the, I mean, it's in the STL has embedded type erasures, so the type of deleter is not the part of the share pointer type. We don't even need to provide the virtual keyword to the destructor to be sure that given object managed by a shared pointer is released. But when we replace it, so we have a unique pointer, we can replace it by the share pointer. So for example, one of our plugins would like to still use that default new and delete mechanism. But in this case, when we have a shared pointer, we can provide in the plugin, we can have a custom allocator, whatever that variable comes from, global scope, whatever. We have our allocator just does allocate mesh loader module, for example, in the pre-allocated memory. And if the we provide as a deallocator the lambda where we pass the pointer allocator, and when share count will be will reach 0 in this case, then this lambda will be called and allocator invoked on the if we invoke deallocate on the allocator, provide the pointer, we just deallocate the object, not the memory, but the object. But there is still a mistake in the designing the plugin API. And this is a question, the second question, what is that mistake? Is anyone who have an idea? It's not the, let's say, the mistake from the, let's say, from the code that you will expect some crash, whatever, no, but from the design perspective, because this code has a very strict rule to follow that is unspoken here, but that breaks the rule that I provided on the few slides before. And the mistake is that we force some compatibility. So as I said, plugins does not check the function signatures. so we need to just rely on the plugin provider that it follow the rules. And if you have a standard C++ library specifying things like type interface, we have a C++ standard. So we need, for example, the string, vector, whatever, need to have a proper methods, or just maybe the computational complexity, but does not specify the type declarations, the requirements for that. So let's assume that our software is compiled by compiler X, but the plugin provider uses compiler Y. So these two implementations, of course, this is just a draft, this small, simple piece. We have a std vector, which implement the rules that we have an add function. We just return the proper element of the vector. We return the size. Here we have a add, again, size index. There's a little difference in the code, but it works same, right? So just the index, this is just the same, size is same, but the order, for example, of the fields is different, which means that if plugin allocates memory for a vector, the data are just placed in the order data capacity size. But our application, when we use the STL, thinks, okay, guy just use vector, and this is the how the fields are placed in the memory, just aligned. In this case, we have a same size, probably, but for example, another STL implementation have a more fields, different memory size, etc. So because every compiler can have a different implementation of STL, this makes a big problem when you would like to support many compiler. So when we have this interface, when we define the interface for our plugin, not only share pointer is using the share pointer from the std is a mistake, but also the vector, string, and every class that is not guaranteed that we have a binary compatibility. Solution. So first one is just require some compiler. So you can say, okay, our software is compiled by compiler MSVC in given version. But I saw that solutions, some engines that didn't thought about consequences of this choice, because, for example, we can have differences with the same compiler with just small updates, small fix, for example, for the compiler, because compilers makes also the mistakes in the implementation, especially in the experimental headers. So the better choice recommended by me and in general by in the programming industry is just you need to implement your interface classes and structures, all of them, when you use it in the plugin interface. So instead of using std, you need to have your own. So vector, base string. So if someone wondered why, for example, Qt have their own QList, QVector, QString, and etc., it's not only because they would like to have more variety of the methods, improve the readability, or just implementing some missing methods that C++ community would like to have in the STL. No, because Qt library also supports plugins. So to fulfill that requirement that you would like to use different compiler and you would like to still have compatibility between plugins and core software, we have our own implementation. So on vector, on string, Then you can decide if you'd like to follow still the requirements of the STL. So if the interface will be same, so empty size, whatever in the std vector, or implement your smaller ones that just fulfill your requirements, and in case of needed, if you need some extension, then you will extend the vector, SharePoint, or whatever or given thing. So if you implement these things, you need to care about the classes or structures that you use in the plugin interface. So some of you can be scared right now because, do we need to re-implement entire STL? The answer is no. You only need to implement the structure classes. You need to just guarantee that binary compatibility from the software and plugin interface. So you can still use STL in the plugin. You can still use STL in your application that loads the plugins, but just need to care about if you make available header files of the STL. Good practice is just to include the STL headers only in CPP files. It's possible to include the vector in the header files, but then you need to guarantee that the structures in header files that includes vector or other STL is not just exposed by the classes that are the part of the plugin. Okay, other limitations. So, any questions at this point? Because I feel that I speak very fast. Okay, what do we have other limitations? So usually when we deal with the API plugins, forget about standard library, and the structure or classes that are the part of the interface needs to be header only. So if you have some logic like the share pointer, of course share pointer and the vector are header only because usually you would like to use the templates. So if you use templates, for sure you would like to have your implementation in the header files. But if you would like to, for example, use as a plugin interface some polymorphism, sorry, forget about it. It's too complex. It's you cannot deliver the implementation of the class, and that is the part of the plugin interface in the CPP file, because for the same reason we would like to use different compilers. Another requirement is that we cannot throw exceptions through the plugin interface. So right now, if we will go back to the code, and for some reason we would like to, let's just run it as a clean. So we can print an info, is the plugin info, which is used in the plugin system and the plugin loader. So if it is used here, sorry, let me find out where it is. Sorry, no, not this handle, plugin loader. Yeah, is it? So despite the fact that we just surround because we have a plugin right here, and we have a get plugin info for this plugin, for the sample is just return here. So we just return the plugin info, sample plugin, the vendor, versions, whatever, and we have a plugin loader. So we can see the output here. Loaded plugin, name of the plugin, vendor, versions. But if we would like to throw an exception like this, we have a get plugin info. We call it here. It is surrounded by try catch. We catch every exception, despite the fact it will not work. The same reason is that C++ standard does not require how compiler implement catching exceptions, FTTI, whatever. There is a very good presentation lectured by Maciej Gajowski. I think it's even on the Wro.cpp uploaded on the YouTube. I recommend you to watch it. It's very, very rich and shows the how exception can be implemented in the compiler. And because every compiler can implement in a different way, sorry, we cannot fit. So it cannot be catched. So this is another limitation. So of course, in the plugin implementation, you can still use exceptions, no problem with that, but you cannot throw the exception outside, let's say, outside the method that is used in the application core. So not in when we cannot catch the exception outside the plugin implementation. Okay, another problem that we can face. So we have a custom shared pointer, so we fulfill the requirement that we have a flexible interface. We provide the binary compatibility between plugin and application in case of that we use different compilers. Are we safe? And of course, if we will, then the question will not be asked. So memory allocated by plugin implementation should be released by a plugin implementation, as I said. And we need to manually open and close plugin connection. But as Wojtek asked, I said that we would like to close the connection to the plugin to control when we allocate and release memory. But the bad thing can happen that we just get the share pointer and save it in our application core, and we close the connection with the plugin. So shared pointer will not invoke the deleter method when the share count is not 0. So the plugin requires more logic and more effort to care about managing the memory. So before we close a plugin, we need to be sure that we released, or just, let's say, destroy all share pointers that comes from the plugin. And there's many ways. Even you can implement your own share pointer with the mechanism that the share pointer will just return you, will say that it's empty when the plugin will be closed, but it requires some effort, some custom implementation, not standard one in the share pointer, which can be not so, it can be counterintuitive, but maybe it's good to consider. Or another case would be just not maybe so efficient, but if you would like to have be sure that you will not have that kind of problems, you can release the connections with the plugin at the end of the application. Of course, there's a problem, not optimal way, because that's why we open plugin and close connection to just optimize the resources. So yeah, as I said, we can have a dynamic memory. Good example can be present here if we, let's say, have a graphic modules, and if the graphic module will be cleared, not cleared, but we will call on our plugin handles, plugin handle, and we just call reset right here. And if we will do it here, then the graphics modules, which is the share pointer to the graphic module, and if we will invoke it, even if we check, for example, if that share pointer right here, if it's if pointing to the address, so, or maybe will be more clear if I will just implement it in this way, despite the fact that we checked if given share pointer is a null pointer, because this pointer points to memory that was still pointing to the memory that was managed by the plugin, but we closed the connection with the plugin, so that memory is gone, and the share pointer, but our default implementation, it's not so smart to tell, okay, that memory was the part of the plugin interface. Okay, so let's talk about how we should maintain the compatibility. So when you design the plugin system, the plugin interface of your application, you would like to divide architecture for modules to be independent from each other. For example, you would like to, when you have a, let's say from the my area, we have a game engine, you would like to have a different module for the mesh loaders, for the image loaders. You would like to have a different module for the additional objects like the particles, whatever, some physics. You would like to allow users, but you would like to divide it on the modules. So the idea that I have in the code that I implemented here, by the way, if you would like to get familiar with this code, I think that I will not have a time to upload it today, but for sure tomorrow I will push it to the public repository on the GitHub. You can look for it on our Quick Turn Studio GitHub. It will be at the you can find it there. So we have a plugin system. The idea is to create the modules. So the main idea is the base. So every plugin I require will have the sorry. I require that every plugin will have a will have the method get plugin instance, which returns the pointer to the plugin pointer, which just gives the plugin info. The plugin info contains the name, vendor, some version of the plugin, version of the engine, if you would like to control the compatibility between versions of the plugins and our software. And we can also, like I implemented here, we can with what modules given plugin supports. So for example, as if in our engine we would like to provide the user to provide the custom backend. So for example, if we have an engine that just relies on OpenGL, DirectX, or just the Welcome, we can implement our own in our architecture. But for example, we have some embedded devices that are they don't support OpenGL, whatever. They would like to have just the simple methods like the canvas, just the draw circle, draw rectangle. We have a very small device, and we have, for example, our firmware that just have a custom graphical API. So we would like to support it. So we have a module interface, which is called iGraphics module. So we specify our requirements. So this is the name of the module. We declare the variable to just don't have a magic string. And we require that, okay, if you support graphics module, you need to implement get graphics module instance, like we have if plugin info. So in my implementation of my plugin system, I require that every plugin will have, let's call it plugin info module, that will inform me about the version of the plugin, vendor, etc. But having the graphics module is optional. So I can tell if I deliver the graphics module by just telling in the plugin info, like here, okay, do you support this module or not? And then if I have application, this is one of the ways, of course, I can, when I have a plugin, and for each plugin, I can ask, okay, give me the plugin info. The plugin info have a field supported modules, and then in my software, I can check, okay, if you support module from the graphics module. If you declare that you do, I will call on the plugin handle, which is the implementation, the platform agnostic. I call the function. It's good to just declare the function pointer type, because this is a template, right? Because as I said before, the operating system just do not check, the compiler does not check the function signature. It just returns us the address, and we need to just cast it. So this is a helper function. Okay, if you have a plugin, just provide me the function pointer type, and we will just reinterpret cast it. And then we have a module, then we can just invoke it. So if you would like to create a plugin, we can just let's just go back to the interfaces. So for example, this is our module. So here's a requirement that every graphics module needs to implement this interface, right? Because this get graphics module instance will return pointer to this interface. So we require that, okay, you need to implement, in this case, one method canvas. If you would like to extend it, for example, create the 3D scene, create the something else. So this is a place where you change this interface, you break compatibility, you don't support backward compatibility, right? Because if you will upgrade your software and you have old plugins, you just the plugin will just not work. And bad news is that you even will not know the reason why. So that's the one of the another disadvantage working with the modules, that let's say that we will make a very simple mistake. So we have an info plugin that right now we use it, and we forget about this small detail, right? And of course, we removed the equal default, right? We declared, right? So we tell the compiler, okay, we will provide you our custom implementation of the destructor, but we forget about it, providing it in the source file. So when you run it, then you will have the crash application. So if you will, I will present you how I do it, but with the DL error, you will just get the message not at the compile time, but in the runtime. So undefined symbol, and this is a mangled name of our class, so you can see it here. Info plugin, info only plugin, our implementation. So comparing to the static, to the shared library, when we compile and we forget about implementation, then we will get an error during the link phase. So undefined symbol, right? Or many others similar, because it's undefined symbol is just comes from GCC. Probably MSVC provides different kind of message, but the result is same. So if this important thing to remember, if you extend your software, if you maintain your architecture, so if you extend your plugin interface, you need to think how you extend. You need to ask the question, do I need to extend the module? So for example, I would like to add support, extend the requirements. Okay, let's put a requirement that our render backend graphics module now not only need to support 2D graphics, but we require to have the 3D graphics. Or maybe you would like to create another module and have two different ones. One graphics module responsible for rendering 2D, and the separate module responsible for rendering 3D. You need to think about designing that kind of interface, let's say, at the beginning. So let's fix that, if I remember it. Okay. So in my example, I have two modules. First one is just graphic module, and I create the canvas 2D. And I provide the interface because I require, okay, this is a shared pointer. In my case, when you will just download the source code, you will see that it's a shared pointer. So it's not for this presentation. I would like to avoid pushing the implementation of shared pointer, the vector, etc. I use one compiler here. That's why it works. But I just use the alias to just give you a table that it should be the custom type, because this is a plugin interface. So I specify, okay, return me the pointer of the iCanvas. So when we create the module graphics, I named it OpenGL. Of course, the implementation is empty. This is only the example. But in the plugin, which is this directory, I create my own class. I inherit from iCanvas 2D. I need to implement all the methods. It cannot be abstract class. It needs to be instanceable. So please remember about this mistake. If you forget about, for example, one method, or maybe you will change a signature, or maybe the header, you don't have the up-to-date header from the software, from the core software in the plugin, then you will experience some issues, and you will see some messages, undefined symbol, crashed, whatever. So this is iPlugin. So in this module, I have that class only responsible for specifying the vendor name, of course, and the list of modules that I support. Of course, one DLL can support many. You just need to provide implementations of the each factory function that will be tried to be open by your library loader. So again, I have a graphics module that just provide the factory function for create canvas 2D. and we just create here our OpenGL graphics module, which instantiate the OpenGL graphics, and we have a create canvas 2D, which just in this case create make shared create shared pointers, allocate object OpenGL canvas, which here is just an empty. And similar thing, we have another module, just again have a dedicated name of the function. It's not the same name, so it's good to just when you create a module, just I implemented it in this way. So I have a interface. I just create the type def of the function pointer, the name of the method, function, and the module name just for the convention that when the application will look for the modules, the logic will be based on this name. And of course, this is a module responsible for the providing the parsers for the meshes, OBG, FBX, Collada, whatever. Do you have some questions at this point?
I guess no questions yet.
Okay. Do we have some time to just?
Yes, we have.
Okay. Let me go back to the presentation just to summarize, and then we can show the small tricks in the CMake that I've made. Advantages of the plugins is that we can allow to extend our application by the third party without exposing source code of our software. We need to just deliver the header files. But we have some disadvantages. So we have a no function signature verification. So we need to keep the compatibility. We need to change headers only when we really need. There is some potential security risk. So if you design your software, you need to be aware that someone can put the library in your plugins directory, and your application will invoke the code. So if you allow for someone else, from the hacker, whatever, to put that plugin into your directory, then you can invoke some code that you would like to not invoke. So when you design your system, you need to be careful about that, or just you need to secure your environment that your application is working on. More complex error handling because we don't have exceptions. We need to communicate. We need to provide some types. We need to think about designing compatibility policy. It's required to do that. If you will not, then you will suffer with the next upgrades of your software and upgrades of the plugins. More complex memory management, because we need to care about cycles and other stuff in the standard smart pointers or just raw pointers, but we need to just keep an eye of the dependency of your share pointers and your library connections. And if you have some missing compiler link server, or just your library will not implement entire interfaces, you will deal with many hours what is gonna happen in your application. And as I promised, I implemented some tools to verify your plugins. So you can see that. Let's simulate the scenario that I forget about putting the external C. But right now, I will not build an application. I will just we like to build plugin sample. So let's just remove all build artifacts to make sure that is done. And when I create the build, you can see that compilation fails. It not failed. It didn't fail because compiler error. It that result returns my plugin verifier. So I implemented something like this. A small application. I have a plugin system, and you have a plugin validator. This is an application that just as a executable argument, just get the path to the plugin that we would like to verify. So I have a plugin path. I access this variable, and there is the entire logic that we would like to test. For example, that's the first one. We just try to load that plugin. So if I forget about extern C clause, okay, then this load plugin here will throw an exception. I mean, not this one, which is not handled here, but I implemented in the constructor in the Unix handle. If I cannot, if the DL open just returns the plugin handle as a 0, then it just throws an error. This is only throwing the exception inside my application. Is not the exception that is thrown from the plugin. So that's is the one of the useful thing. Just in the plugin validator, we just try to load that plugin. We can put another requirements. So for example, if I do not provide the name, the vendor, whatever, then I can just also return non-zero error code from our application, which will just break the compilation. Just so let's assume that still I have external C, but oops, I forget about providing the name of the plugin. So still I will get an error. Plugin path to the plugin has no name, right? How I did that. So I created the where is plugin system? Here's the CMake, yes, right here. So I use my custom CMake command, which is it's add plugin, very simple add plugin name, and I provide the source files. Implementation is not so complex, but I create the library. Is just the CMake command delivered by CMake. So we create a library with the module one. RGN, that's our extra argument from the CMake. If you are not familiar with it, it's a very, very good tool. If you would like to provide just maybe not infinite, but many arguments in the CMake function, then I add dependency to the plugin validator. Why? Because I would like to execute the plugin validator application after building my plugin. So I call the function add custom command. I have a target name, which is my plugin. So I tell to the CMake, okay, when you will build my target, just after the build step, just invoke plugin validator and the path to the plugin. Right, so firstly, we guarantee that plugin validator application, which is here, right? This is this application in this module. I will invoke after the build of the plugin. And I also, there's a small improvement. I use the position dependent code compiler flag. And if we are building our, if we build our application or just plugin with the MSVC compiler, we need to add those keywords. Let's call it. Sorry, I don't use a keyword. The compiler specific thing. So I declare the definition by the target name API. So if, for example, my target name is the plugin sample, like here, so it will be the plugin sample dash underscore, sorry, API. Same for the OpenGL graphics. If I have a OpenGL graphics plugin, I have it just creates me the definition OpenGL graphics API. That's this. This is the responsibility of that compile target definition. It just replaces it when we compile by Microsoft Visual Compiler. We just use this. And of course, if you're on the Linux, we don't need to provide. Important trick is we need to provide an equal mark, because it will just be definition that we can check if definition is defined. But if we put an equal sign, then we just tell the compiler, okay, replace every appearance of that definition, just replaced by the empty. And the second thing is that we would like to, from the build system perspective, when I would like to use some plugin, I would like to just tell, okay, the dependency of this application are this plugin, or this plugin. The CMake unfortunately does not have it by default, because shared libraries are linked during the build time to the application, but the modules, I mean the plugins, we open by ourselves. So I implemented some tricks. So if I tell, okay, here's a dependency plugin sample, if I run the application, you can see that, the plugin has no name. Let's revert that. You can see that I built an application and there is no linkage, so I add the dependency myself. So you can see that if you will go to the build directory, here is our application, and it created the plugins directory, and I have all parameters that I have. So for example, if I would like to add the dependency to the second plugin, OpenGL graphics, then you will see, okay, my build system placed the plugin sample, of course, after putting in the plugin validator. Implementation is a bit more complex. I use CMake parse arguments. Let's skip what is exactly that function command responsible for. In general, I just iterate through every dependency. I mean the plugins here. I iterate through that list, and then I just add the dependency. So if you would like to build application, firstly build this target, which is plugins. Then we would like to add automatic way. If you will build a plugin, then put it in the right directory, because application looks for a plugin in the directory that is just programmed by programmer, right? We need to, in the program, specify the directory where our plugins needs to be placed. So we create some file. It's just the target name, just txt. There is a content of this file is not important. We would like to just replace the, in case of here, because it's a target name, we have colons here. Colon is not the valid mark for the name of the file in the system file. So we just replace it by the 2 dashes. And then we just provide this file as a source of our application. What does it mean? It means CMake, when you click build or just invoke CMake build target, it will check the checksums of each file that is a source file, CPP file, right? And if we put that your source file is this txt file, this txt does not contain any code, but when we rebuild our plugin, if the plugin changed, also the this txt will be touched, right? So the file will be touched. So the CMake recognizes, okay, the source file has been changed. So we need to recompile. So we need to invoke the command, which is, because this is a source file, so if this file has changed, then we just make a directory, which is a plugin, and then copy binary if it's different to the directory of the plugin file. And that's, I think, entire logic here. So in general, firstly, when you build plugin, run the application responsible for the plugin verification. For example, if the plugin is able to open, if all modules are implemented properly. So for example, in this case, what is missing, we can place, let's say, if you implement a given module, check if you have a given function pointer exposed, and other requirements that you have. And then just add the dependency in build system between application and plugin, and during the build time, when you build application, put the plugins in the right directory. Okay, do you have some questions?
I have one question.
Sure.
So
Don't be shy.
I'm not shy at all. So you present this plugin validator. It's pretty awesome. And I was just thinking, have you been considering or trying out using read ELF to to dig out the symbols out of the library and check if all the functions that you require are in place? Or is it something that is unusable in practice?
I mean, it's the platform specific. So
yeah.
In our case, in this case, I prefer just to verify it just by loading the plugin, right? So in the plugin validator right here, which is is the plugin validator, right? I just load this plugin. And that loading this plugin is this plugin loader.
Yeah, so it will handle those situations when there's like lack of symbol, which Lincoln needs. And I've been just thinking if there are maybe some other issues that might be discovered by checking the symbols within the library. But I'm just
I mean, just your way of that, you can just iterate through the symbols, no problem with that. But I mean, this scenario is even more, right? Because we validate entire way.
So, fine.
Right now, for example, in this implementation, as I said, I just test with the load plugin. So I test only if given plugin implemented this function and expose it, of course. The plugin instance, what let's say is missing from, let's say, this case of perspective. So I don't validate the logic if someone in the plugin info, if someone declare like, for example, here, I have a module, here, and we check, okay, and the plugin declared that it support module name, so it should expose this function, right? Because I assumed that it be, right? So if you support this module, you should also provide this this function. You should also expose. So that's, for example, the next step for checking. If you declare that you implement this module, just check if you provide proper method. Because as I said, given plugin doesn't need to implement expose all that factory functions, that module. So for example, my OpenGen graphics expose this get graphics module instance, but don't expose the method get mesh loader module instance, right? So assumption of my plugin system is, okay, every plugin needs to deliver expose for me get plugin instance to just provide me an info that I require, but then rest of the functions are optional, right? So you decide, right? For example, this plugin just provide a get plugin instance. This is a sample. This is just the example, the minimal implementation of the plugin, right?
Okay,
so
thank you.
Yeah, so I didn't say it explicitly. So for example, if you have your software and you would like to extend your software, if you consider adding new functionality, okay, I would like to letting the user extending another area, probably it's better to create new module interface, right? So new directory, new let's say function that will be exposed. So the previous plugins does not need to update their implementation, right? Because I only care about this module. I only expose this plugin instance, and I only expose method responsible for meshes. I don't care if you extend it by the 2D, 3D, whatever, right?
Okay. Thank you for answering that.
Do you have other questions?
No question from chat, so.
Okay, so thank you very much. As I said, I would like to put a little advertisement here. I and my team implementing the strategy game. It's called Whispers of Ellenrod. We will release a demo in the next year. If you would like to get familiar with it or just sign up to the mailing list, I would like to enforce you to do that, because you look for volunteers to beta testers before we release the game. The demo is for free, so don't hesitate. Just enter our website or just contact me. I will for sure will contact with you. And thank you very much. And as I said, I will upload this presentation, and I will upload the source code to the GitHub. So if you would like to just look for this code, just put QuickTurn Studio, not the QuickTurn Games, QuickTurn Studio on the GitHub, and I hope it will be available at least tomorrow.
When you will upload it, just let me know. I will ping everybody about it.
Sure.
That will be easy. Okay. So thank you, Sławek, for your time and awesome presentation. I hope we will see on the next meetings as well. And yeah, good luck with your new game.
Thank you very much.
As well. Yeah.
I appreciate that.
Thank you once again, and have a good night.
Thank you for organizing this. Bye.
Thank you. Bye.